Welcome back in with Academia. I'm Richard Price, founder and CEO of Academia, and as I here to explore fresh research from the academic, sharing ideas to help you their years of knowledge in a new light. Today I'll be discussing a really fascinating paper by Rajiv Singh titled Recursive Vision Computing, a Self-Refer Framework Adaptiveception. Before we get, just a friendly reminder that is present the paper's findings and arguments neutrally. I'm not or endorsing the paper. My aim is to outline the research and its relevance for you, so you can reflect, question, and see what sparks your curiosity. All right, let's dive. The core question Rajiv Singh is asking is one sits the heart of artificial intelligence. What does it take for computing to adapt, to learn on the fly, to rethink how they see the world like living beings do? Why do today's smart cameras and image recognition, amazingly as they are still stumble when environment changes or when things get a little unexpected? If you've ever wondered why even most advanced computer vision models can be thrown off by a smudge on a lens, a weird lighting angle, or a totally new object, this paper is going to be right up your alley. So, what's the big deal? Well, traditional computer vision systems are built mostly as pattern recognizers. They look at an image, crunch some math, spit out a prediction, and move on. But they don't really know that they're seeing lack an internal sense of own perceptual. It's like, imagine if you could see the world, but you'd tell if your own eyes were adjusting to darkness or getting confused. That sounds a bit sigh, right? But in reality, humans are great at using feedback. We don't just see, we monitor how we're seeing. We notice when something feels off, and we recalibrate. That's part of makes human perception so robust. Now, Rajiv Singh's paper proposes what calls a recursive vision computing framework. Idea is to add a referential recursive layer to vision models. Of a one-way flow, image comes, prediction pops out. The system actually models its own act of perceiving. It's as if the AI remembers or reflects what it just saw and how confidently it saw it, and then can loop back into refine. It's almost like a short-term memory. Let me break the main components for you. First, you have the standard perception pipeline, the neural network or whatever tech is extracting features from the visual input. No surprises there. But Rajiv's framework adds an observer modeling layer of like an internal journal. The system keeps about its own perceptual state, confidence, uncertainty, the context of its predictions, that sort of thing. Then, and where it gets interesting, there are recursive feedback controller. This bit takes the internal observer's thoughts and cycles them back into the vision process. What that practically, if the system's about an image, say there's unusual lighting or part of an object it iterate using observer model to am seeing for what context am I confident? The answer is no. It can weigh different features differently, shift its attention, or even wait and gather more before making a final call. Instead being locked into one shot, the vision system becomes, adaptable, kind of like a human double-checking before jumping to conclusions. And here's where I go off on a tangent. The concept of reflective perception machines is almost philosophical, don't think? I mean, what are you to know you're seeing? Do plants have a sense of perceiving, or is just us? Let's it back in. Why should you care about any of? Well, if you with technology, robotics, autonomous, maybe even imaging, this could spark new to systems and more reliable. If a robot can notice that it's confused, it could pause before acting rashly, improving safety. Or, in medicine, a diagnostic AI that knows when doesn't know could urge the doctor to take a second look. It's important, though, to remember this just one paper. These ideas aren't established fact. Research includes conceptual models, some algorithm, and early ideas for experiments. It's not the finish line. It's like a new lens to see machine perception, a blueprint to be tested, refined, challenged, and maybe drawbacks. More computation, failure modes. Critical is key. As we wrap up, remember, academic research is a journey. Each paper is a stepping stone, not absolute truth. Singh's work explores I'm here, just presenting his vision, not promoting it, how we might build machines that see more self-awareness. The time you use face recognition on your phone or a self-driving in the news, or is it flying? Thanks for tuning in depth with Academia. I hope today's episode helped reflect on what means for machines and for us to catch next time for another journey into the wild world of research.